So here is a data set of the distance from the coast and the percentage of weekly fish eaters. I'm going to make this full size here. One way we can look at this data is with a scatter plot. So let's go ahead and create a scatter plot. Insert scatter plot. There we go. Select data. Add series name. Let's call this percentage of weekly fish eaters. X values would be the distance from the coast. That's our independent variable. Y values would be our percentage of fish eaters, weekly fish eaters. There's our Y value. Okay. Okay. And there's our little plot. It's only one set of data, so I'm going to get rid of this. And go on over here. I've gotten rid of the legend, but let's go ahead and add my axis titles. There's my y-axis, percentage of fish eaters. Let's also add my x-axis. Horizontal. Distance from coast. And let's title this as the title of the question being asked by the researcher is seafood interest related to coastal proximity. There we go. And there's our data. You can kind of look at this. And it does look like it's slightly sloping down. Let's go ahead and change our axis just a little bit. Since we know it only goes from 0 to 1, because that's a percentage of fish eaters. So 0 to 100 is the y-axis. Format the axis. Make the maximum at 100. And it looks like our largest x is 3,000, so let's also format that. Format the x-axis, fixed at 3,000. There we go. So there's our data. Well, here's a data set, and we're supposed to determine if this is correlated or not. Taking a look at it, can't really say it's highly correlated. It does kind of look like it's slightly sloping down, but not that strong. Now let's go ahead and now play with this data. If you recall, I'm going to bring back up PowerPoint for a second here. We have Pearsons R, which is this equation here. And in this equation, make that full size, we have the sum of x minus x bar, sum of y's minus y bar, and then we have the squares of those aspects multiplied together. Let's calculate Pearsons R, shall we? So here's our, let's insert a row here, insert row, and find my average, insert column, average equals average. We'll quickly find our averages here. 774 is the average distance from coast, and 71.95 is the average percentage of fish eaters. Here's our x sub I minus x bar, and we'll put here y sub I minus y bar. Let's go ahead and find out those items. Equals x sub I minus x bar. Let's hold that constant. Dollar. Same here. And returning now to our equation once again, we have x sub I minus x bar times y sub I minus y bar. There we need it squared. All right. So here's our x sub I minus x bar times y sub I minus y bar. And here we'll go ahead and put x sub I minus x bar squared at 2. And there we'll put y sub I minus y bar. Notice I'm copying and pasting just to make my life a little bit easier. And one other thing I'll do, I'm going to go ahead and wrap text to make sure everything's easy to read. It's still not quite totally easy to read, so I'm going to flatten this out. There we go. This equals x sub I times y sub I. There, that's that product. Here's that product squared. And there's that product squared. Copy, paste. We now have all of those items calculated. You can check them. Always nice to check to make sure we're calculating what we wanted to. That is my average. There's that. There's, yes, that is, yes, that's correct. Yes, that's correct. And yes, that's correct. Going back to our equation, we need to, not this equation, we need to sum this product of x sub I minus x bar and y sub I minus y bar, sum all of this, then take the square root to find Pearsons R. So let's go ahead and do that. Now let's find the sum equals sum of this. Find those sums and that sum. Look back at our equation one more time. So we have all of these sums. We need to multiply the denominator, take its square root, and we'll find Pearsons R shortly. So therefore, Pearsons R equals this divided by the square root of this times that. So we have negative 0.7428. Quite a bit of work. Fortunately, Excel would have done this for us too. Pearsons R. To find Pearsons R with Excel, just type in Pearson. And look, it'll find Pearsons R for us. Notice it doesn't matter which one's X and which one's Y in finding Pearsons R, but it will matter when we try to find the slope or conduct the regression. So there we have it manually, and there we have it automatically. 0.74. Now let's look at what that implies for Pearsons R. 0.74 is between 0.6 and 0.8. That would imply a strong level of correlation. So this is strongly correlated. And is it positive or negative? Negative correlation. There we have it. Strong and negatively correlated. We can also look at R squared equals this times itself. Put that in percentage format, and we can interpret this as 55% of the variation in seafood interest is determined by coastal proximity. Interesting. Notice here I've said it's strong and negative correlated, and I also give this simple statement that a manager can understand. Given these three statements, a manager can understand how much he should count on distance from the coast to imply seafood interest. I should note, in case you're curious, again, this is fictional data. This is not realistic data. So here's one level of analysis of correlation given two pieces of data. Let's now do a regression. Since I've already used this spreadsheet slightly, I'm going to go ahead and open up a new spreadsheet. Insert a new spreadsheet. Move this over here and copy my fish data. Copy my fish data on over. There we go. So here's my fish data. Copy. I'm going to go ahead and place it here. And I'm going to take this whole column and have wrap text on the whole column. Let's now do a regression. Let's look first at what the regression equation requires. So we're going to do this manually, and then again we're going to let Excel do this for us. So, jumping down to correlation, we have the equation for the slope, which we must find first, requires the sum of x sub i's and y sub i's minus the sum of x sub i's times the sum of y sub i's. And there's the x sub I squareds minus the sum of x of I squared. Quite a few sums. Follow along with your book. Might be a bit easier. So let's go ahead and work on that. First of all, we need the sum of x of i's. Wait, which one's x and which one's y? Distance from the coast would probably be x, and this would be y. All right? And we're going to need the sum of x sub I squareds. So this will be x sub I squared equals this times itself. There we go. Copy. Paste. So that's the x sub I squared. I'm going to go ahead and freeze my pane so this doesn't jump around too much on me. View, freeze pane, freeze pane. There we have it. Now I need the sum of, I also need x sub I times y sub I. So let's go ahead and find those. Equal that times this. Copy. Paste. And I'll also need lots of sums. I'm going to insert another row up here. Insert row sum equals the sum of all of this. Sum of that, sum of this, sum of that. I think it's time now. I'm going to insert one more row. Insert row, average. Let's also find our average distance from the coast once again. And our average percentage of eating food, eating fish. There's our weekly percentage of fish eaters. Excellent. Okay. Now let's find our slope. We have the equation listed on page 169 of our workbook. And our slope requires that we find the number of data points. So I'll call that the count, or n, and we'll just count up the number of data points to quickly identify how many data points we have. We see we have 20 data points. Now our slope requires, our slope, or m, equals, using the equation directly out of the book, the n times the sum of x's times the sum of y's, that's this term here, minus the sum of x's times the sum of y's divided by, open parentheses, n times the sum of x's squared, that's this term, minus the sum of x's squared. Close the parenthesis. And we have a negative term, negative 0.02. Now, does this make sense? Well, yeah, because we looked at it earlier and it was negatively sloped. We can go ahead and remake that plot quickly if we wanted to, or I can just simply copy and paste the plot. Copy, paste. So there's our plot right there. So yeah, it makes sense. I'm going to go ahead and delete the data and then insert it again. Why am I doing that? Because I want to work with one spreadsheet at a time. Add series name. I'll just choose the x values, distance from coast, and the y values, percentage of fish eaters. Okay. So there's our plot of the actual data. I am going to go ahead and label this actual data. Format data series. Oops. Select data as actual. Because we're going to make predictions. So is this negatively sloped? Yes, it is. So that makes sense. Why is it so small? Well, because this is thousands of miles, and this is only a 0 to 100 scale. So yes, it makes sense that it's also a small number and that it's negative. Next, let's find our intercept. That's b. b equals our average, right there on page 169, our average y, which is this, minus our slope times our average x, which is that. And our slope is 94. I'm sorry, our intercept is 94, which again makes sense. If x is 0, we should be pretty close to 100%. And it is. It's about 94%. Excellent. Let's go ahead and make predictions now. We're going to try to predict our y's given our x's. We have these x's. Let's go ahead and just predict our y's. Equals. Y equals mx plus b. So y equals mx plus b. There's our prediction. Well, the first piece of data predicted 75, but we only got 68. It's a bit high. Let's see how our other predictions go. I'm going to go ahead and remove a lot of these zeros because we know our prediction isn't going to be exactly right. I'm going to add some dollar signs so I can copy and paste it on down. And copy, paste. We have a lot of predictions. Here we're predicting high, here we're predicting high. There we predicted 48, but we had 63. Here we predicted 93, but we had 99. So sometimes my prediction is too high, and sometimes my prediction is too low. Let's see how well it looks if I plotted it. So I'm going to go ahead and select more data, design, select data, add. I'm going to call this predictions. Using my x values, which I had used, and my y values here of my predictions. Okay, okay. And we see our predictions and our actual data, the blue, are not too far off. I'll tell you what, at this point, I'm going to go ahead and add the legend in since I'm plotting two pieces of data at the same time. I'm going to add it below. There we go. Whoops. Legend. Below. There we have it. There's our predictions. You see, here our actual is above our prediction. Here our actual is way below our prediction. But generally our prediction went down and our average data did go down as well. So here's a manual way of doing the slope. Is there another way of doing this? Yes. You can also just use the Excel function slope. And look here. It says give me my known y's, comma, give me my known x's, and that should give me my slope. And it did. Is there an easier way to find the intercept? Sure. Equals intercept. And that'll say, give me my known y's once again. And give me my known x's. Okay. Comma. Known x's. And there's my intercept. You see I got the same intercept. So we can do this manually, or we can let Excel do this for us. And that is our downward sloping curve. There's even yet one other way to do this. I'm going to insert another new spreadsheet, move it back over here next to our fish data, and let's copy and paste my data one more time. Copy and paste. What is the one other way? Well, let Excel do all the work for us. To do that, I'm going to go to Data, Data Analysis, and look at these terms. One of them says Regression. I'm going to choose Regression. Okay. And we're going to use the Excel Data Analysis tool to do the regression for us. So I need my Y. Do I want to use my labels or not? I think I will. I'm going to use my labels. Y range, that's here. X range, that's the distance from the coast. And I have my labels. I'll leave the rest of this the way it is, but I do want to choose my output range so it would put it on this same worksheet. I'll put my output range here, and I'll say OK. I'll leave the rest of this blank. You can play with this on your own if you wish to. Quickly, I get all of this data. This first column is too narrow to read, so I'm going to make it wider. There we go. And let's zoom out a little bit and see what I have. Aha! There's my multiple R, my Pearsons R. More specifically, it's my absolute value of Pearsons R. And this is 74. So this would imply a strong correlation. This is the absolute value of R when you use the data toolbox from Excel. It doesn't tell you the positive or negative. We know it's negative. We found that back here, negative. Okay, our R squared of 55%, so that implies that 55% of the variation in fish eating is dependent upon distance from coast. So we're just trying to read this. Adjusted R squared, some researchers use this. We will not. Observations, there's my count. This is the number of data points. We have 20 data points. There we have it. Our standard error we're also going to ignore. Here's my ANOVA. Remember we talked about the ANOVA table before. There's my significance of F. It's some term. My F stat, etc. My degrees of freedom in this case was 19. We don't have to worry much about the ANOVA table. What are we really looking for? You got it. P-value. There. We'll be looking at the p-value and the coefficient standard error. We'll also look at our t-stat. So I'm going to highlight all of that. Selecting it and highlighting it. And I want this term as well. Okay. In fact, I'm not interested in this at all, so I'm just going to delete it. How do we interpret this? P-value of 2.3 e negative 11. This is times 10 to the negative 11. So is that above or below my alpha, my significance level? Well, my alpha I'll choose is usually 5%. 10 to the negative 11 is definitely less than 5%. So this is less than alpha. That implies that I will reject my null hypothesis, accept the alternative hypothesis, or otherwise declare this statistically significant. Next, I have this p-value. That too is definitely less than 5%, so I'll also declare that statistically significant. So both my intercept and my slope are statistically significant. So I'm going to go ahead and, say my intercept is statistically significant and my slope is statistically significant. Very important statements. Remember, we're trying to figure out what's important. And, this data is, statistically significant. So there's my correlation. There's my t-stat. I said I was going to use this. How do we use that? Well, a t-stat is a lot like a z-score. It's like how many standard deviations you are away from 0. And here's our standard error. Remember, we talked about standard error in an earlier video as well. In effect, we're saying that the intercept is 94, which we had calculated, but Excel does it for us, plus or minus a standard error of 6.52, or 2 standard errors would be the 95% confidence interval. 2 times 6 is 12. 94 plus or minus 12 is nowhere close to 0. So we know that this is statistically significant from 0. Statistically significant, it is non-zero, and our t-stat says it is 14 standard deviations away from 0. Roughly, that is a way to interpret it. We are 14 standard deviations away from 0. So our coefficient of our intercept is definitely non-zero. I'm going to get rid of some of these commas. There we go. Now let's take a look at our second coefficient, our distance from the coast. This is our slope. It is negative 0.03, and our standard error is 0.01. 2 standard errors on the 95% confidence level, it would be 0.02, which still won't put us at 0. So what we're saying here in our t-stat is that we're actually about 4 standard deviations away from 0 for the slope. In other words, Although this is small, it still is not 0. So our slope is statistically significant and non-zero, and our intercept is statistically significant and non-zero. So if I wanted to write a line, which you know I often like to do, I would say that the percentage of weekly fish eaters equals my slope, negative 0.03, times my distance from coast in miles, plus 94. That is a nice and simple way of describing what we learned by examining this data. Something you would just share with your boss. I'm going to show one more thing in Excel. Back here, we made a plot of the seafood interest, and we found the line at the prediction. Is there an easy way to find the line? Yes. I'm going to select the actual dots, the actual data, and I'm going to just add a trend line. I'll use linear because I'm doing linear regression. Say close, and look, you get a trend line right through there. Excel will also quickly plot trend lines of the linear regressed line for you. And here's a nice example of our regression analysis. Another kind of regression we might do is multivariate regression analysis. I'm going to choose to look at Aladdin to show you an example of multivariate regression analysis. Here we have a Y of auction price and two X's, the number of bidders and the age. I'm going to insert a row here, call this X1, X2, and Y. Now to regress this, the equations get quite difficult. Fortunately, Excel will do all the regression for us, even multivariate regression analysis. Go to Data, Data Analysis, stick with Regression. In this case, we choose our Y of our auction price. I did choose to put the Y in there. And our X is both X's, X1 and X2. I'm going to choose both of those X's. I do have my labels. I'm going to put my output here. Okay. Let's zoom out. So here's my intercept, my B. Here's my slope for X1, and here's my slope for X2. Looking here at my p-value, you find that X1 is not necessarily statistically significant, nor is my intercept, but my X2 is. In any case, though, we could write this regression line as Y equals M1 X1, or 0.000162 times, X1, plus M2 times X2, that would be 0.096769 X2, plus my intercept of 0.825696. So here's a way we can do regression analysis. The rest of the interpretation with multivariate regression is the exact same way as it is with linear regression. I just wanted to show you how Excel can handle two X's. All you do is select both of them at the same time. And when you're interpreting it, we now have a slope 1 times X1 plus the slope 2 times the second X plus the intercept. And notice here I had selected my X's, and there, and so everything was easy to read and interpret. Armed with this data, you should be able to do real estate values, Tivoli, gambling, crime, and correlation. Aladdin isn't the only breadwinner, sales by territory, and used cars. Now, in looking at regression, we've also looked at correlation and other factors, causation. One of the things that as marketers we worry about a lot is our pricing and our quantity sold. We often believe that higher prices yield lower sales, which is true for most products. It's not true for all products. Some products you can actually price higher and get more sales. As marketers, we can always test this hypothesis. And in doing so, we'll just do a simple regression analysis where price is the independent variable. That's something which the marketer controls. And demand, quantity sold, is the dependent variable. In our exercises, some of them require you to actually look at prices and demand, doing a correlation and making predictions. I wish you luck. That completes our video for Chapter 9. Next week we'll look at Chapter 10. A deeper look at hypothesis testing and a summary of the different ways in which we'll examine data statistically.